going to be solving compound inequalities, which is in our learning goal over here. It says you should be able to, this is what your goal should be after while you're working on the homework and after you're done. I can solve and graph solution sets of compound inequalities in one variable. In other words, there'll only be one variable involved, even though there's really actually more than one inequality involved. So, what are compound words? What is a compound word? Back to English class.
Two words that are put together with the word or. No, that's a sentence. Compound sentences with.
Compound sentences with two thoughts put together with the words and or between them. What's a compound word? Morgan.
Having two inequalities.
Compound word. Just go back to English class, not math class yet. English class. What's a compound word? Or can you give me an example of one? We're going to go ahead and try to get backyard. Okay, and backyard is made up of two different words that are words by themselves, but put together they make another word, right? Okay, so a compound word is a word made up of two words, but yet they work together. They can come up as a word. Isaiah.
Can I answer the next question here? I feel like I know the next question.
So you think you know what the first thing is fill in the blanks here? Is that what you're saying?
Yeah.
Okay. So what are compound inequalities then, Isaiah?
Two inequalities that are joined together with the word.
So compound inequalities are two inequalities. Let's get that filled in then. So if we have a compound word is two words, a compound inequality is two inequalities. But they are joined together with the word. In fact, somebody's talked about a compound sentence. That was Ricky, wasn't it? So what a compound sentence can be put together with
Or and.
and we'll use the word and first, or the word or. So our two inequalities will work together using the word and, or they will work together using the word or. So let's think of a situation such as where sometimes, what does and mean when we're talking about two inequalities working together? What does that actually mean? What do you think? Isaiah?
The word and would mean that they are like they have the same value.
Yeah, let's just talk about a situation like last weekend was just Halloween. And if you wanted to go out, let's say you were some friends wanted to know if you could go out to Acres of Terror with them. And your parents said, so you went to your parents and you asked, can I go to Acres of Terror with so-and-so? And they said, well, yes you can, if you get the dishwasher loaded and you pick up your room. Then you can go to Acres of Terror. Tell me what's the deal? And parents do this, don't they? Yeah. And what's the deal? When they say it like that, what's the situation, Isaiah?
Means you have to do both.
You have to do both. You're not getting to go until you've got both of them done. What if instead they say, you may go if you load the dishwasher or you pick up your room?
You have to do
You only have to do
You
one
pay
or
your
the other.
sister
You
to
get,
do it.
yeah, you get picked. You get to pick which one you want to do. You can pay your sister to do it in the other situation.
I do it all the time.
So, but in this, so if they say or, you could either be a nice, son or daughter and just do both of them anyway, or you could say, well, they said I only have to do one of them, so I'm only going to do the load the dishwasher. My room is terrible. Okay, so and or, that's when we think about and, we have to think of they are working together, and it has to match both situations. It has to satisfy both. When we talk about or, we're saying, you know what, it can satisfy one or the other. It does not have to satisfy them both. So when we graph our compound inequalities, we're going to graph them on the same number line. We're going to show that solution set. They're working together, even if only one of them has to be satisfied or they both have to be satisfied, they're still working together. So when we have an and compound inequality, we have where the values where both of the inequalities, just like load the dishwasher and pick up your room, both inequalities have to hold true. In other words, any values you choose for the variable have to make both inequalities true. So here's an example. We have negative 3 is less than or equal to x, and it's not written in there, but it is known that the word and is here, and x has to be less than 3. So let's write that out. Let's separate that out and write them as two simple inequalities. We have x, we're working from the inside out, we're reading it backwards. X is greater than or equal to negative 3. And not only does x have to satisfy that, but it also has to satisfy x is less than 3. So give me some examples of value x could be that would satisfy both of these. Michaela, you give me one.
Negative 1.
Negative 1. So negative 1 is in here between the two of them, and negative 1, is negative 1 greater than negative 3?
Yes.
Yes. Is negative 1 less than 3?
Oh, yeah.
Satisfies both of them. That would be a good one. Morgan?
1.
1, positive 1. Positive 1 is in between here too. Is positive 1 greater than negative 3?
Yeah.
Okay. Is positive 1 less than 3?
Yeah.
Yeah. Okay. Christian?
0.
0. Okay. Is 0 satisfy both of them?
Yeah.
Is 0 greater than negative 3?
Yeah.
Is 0 less than 3?
Yep.
And again, 0 is in between these two, isn't it? Okay, now let me ask you. How about negative 3?
That's what I was just gonna
Yeah.
say.
How about negative 3?
Yeah.
Is negative 3 greater than or equal to negative 3?
Yes.
Yes. Is negative 3 less than 3?
Yep.
Yes. If we can say yes to both of them, then it is a solution also. How about positive 3?
No.
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 Why not?
Because it's not less than 3. 3 is not less than 3.
It does not satisfy the second inequality. 3 is greater than negative 3, is it not? Okay, that's a yes. Is 3 less than itself?
No.
No. There's a no there. It didn't satisfy the other one. So we would put an open circle at positive 3, right? Because we decided that one can't be a member of the solution set. We decided negative 3 could, so we would put a closed circle at negative 3, and all those other values you chose were in between the two of them, weren't they? How about 10?
No.
Which one doesn't 10 satisfy?
The second one.
The second one, x is less than 3. How about negative 1,000?
No.
Which
No.
one doesn't that satisfy?
That one.
The first one. So we have those that they satisfy one of them, but they don't satisfy the other one of them. We can only pick the region to shade that satisfies both inequalities. Isaiah?
So, is it at all possible for them to have for any number to not satisfy either of them?
Oh, sure. We could have a situation maybe where it wouldn't satisfy either. Okay.
This one seems very, very easy.
The one we just did?
No, I mean like this entire lesson seems like it'll be very easy.
Guess what? It's just the beginning.
We'll see.
You got a curveball in there. You be quiet and watch.
How about or compound inequalities? Let's talk about that. Let's talk about, remember you said
One
you could
or
either
the
load
other.
the dishwasher or you could pick up your room.
So we
And we decided in most cases it'd probably be better to choose loading the dishwasher because your room might take a lot longer.
My room's big and small.
Oh.
it could be like
So,
it could be one or the other.
right, it has to satisfy one or the other. It does not have to satisfy both of
It does
them.
not have to.
Ricky,
So they could it.
it only has to satisfy one or the other. Yes, it could satisfy both of them, but for an or situation, it only has to satisfy one. Just so, or compound inequalities are where either one, you get either one of them. So either one or the other, the two inequalities are true. It only has to make one of them true. It does not have to make both of them. And notice the difference between our example this time and our and example when we're talking about it in algebraic form. Now we use the word or between, we don't write it all together with just one x in it. We have to have it separated into two simple inequalities when we have the or situation, okay? So keep that in mind, you will always use the word or, not just one x in the middle like we did up here for the and one. Okay, give me some examples of numbers that you think are solutions to this one. Christian?
7.01
7.01, okay? Why?
because it's 1/100th greater than 7.
Oh, okay, but it's not less than 2.
Doesn't matter. No, it's not less than 2. It doesn't matter.
Why doesn't it matter?
It's or.
It's or, it only has to satisfy one, and it satisfies the second one, doesn't it? Ricky?
0.
0. Is 0 a solution?
Yes.
Okay, because why?
Because it's less than 2.
Because it's less than 2, it satisfies the first inequality, but it's not greater than 7.
Heck, 2 and or 7.
How about it doesn't satisfy the second one? It doesn't have to. No, it doesn't have to. Morgan? Pardon? 7. Okay, how about 7? Is 7 a solution? Okay, why?
That's equal to.
It's equal to, it satisfies the second inequality.
86.
So how about 5?
No,
Why not?
it's in between.
Well, in between ones worked last time.
Because it's not greater than 7 or less than 2.
Yeah, it's not either. It's not less than 2, nor is it greater than 7. 5 is in between them, like you said, but not satisfying either of them. So when we graph this one, do we want an open or closed circle at 2? Closed. And what direction do we want to shape to show all the numbers that satisfy that one?
Left.
To the left, okay? And graphing the other one, what kind of a circle at 7?
Closer.
Closed circle, and notice that we're not doing the integer neighbors here, we're just doing those two endpoints now. And which numbers satisfy the second inequality?
Everything to the right.
Everything to the right. So we graph them independent of each other because both of them, as long as the solutions come from one or the other, but they're combined on the number line showing all of these x values would work.
So all we have to write is the 2 numbers.
Yep, this time you only have to write the 2 endpoints, okay? You do not need integer neighbors, okay? Okay, any other questions so far? Okay, let's look at the first thing we're going to try here then. Write the compound inequality shown by the graph. Okay, so what is this one showing? Let's write the simple inequalities first and then decide if we should use the words and or, okay? So when we have -5 and it's shaded in and it's shaded to the right, what simple inequality would that one be? Ian?
X is greater than or equal to -5.
Okay, that one would be x is greater than or equal to -5. So everything shaded to the right would be included there, correct? Okay, what is the other one then, where we have an open circle at -3 and now it is shaded to the left? Which one, what's that in a simple inequality for that one? Michaela?
X is
Less than what?
negative.
-3. Okay, now we gotta decide if this is an and or an or.
And
What do you think, Sam? Is this an and or an or?
And
Okay, why is it an and? How can we come to that conclusion?
because they're shaded in between.
Because it's shaded in between, okay, that might be one of our clues. Okay, Michaela?
That X value where it's shaded is satisfying both of
Okay, yeah. Notice how it got cut off. It was being shaded to the right, but then all of a sudden it stopped at -3, and it's no longer shaded that direction, is it? Because now those values would not satisfy the other inequality, and so we only have the numbers that are satisfying both of them. So this is an and situation, but we don't leave it like that. You will not see it in an answer bank usually written like this. This is one where we can shortcut it and write it as a compound inequality with only one x involved in it. So we would put x in the middle, put just the way it lays on the number line. -5 comes before -3 on the number line, so -5 would be at the left end of our compound inequality. -3 would be at the right end of our compound inequality. And now we'll say, okay, I gotta read this backwards. X is greater than or equal to -5, or we could say -5 is less than or equal to X, right? And then this one is already written in that order, so we're just gonna leave it like it is. This is our algebraic solution for, that was the graph solution set that they gave us. We wrote it algebraically. Sam?
So that, is that all that's showing for these?
Yep, that's all there is to showing word for these. Okay, let's try the second one. Okay, what's this inequality at the left end? Riley?
-4.
-4. Just -4? What's the inequality that describes that graph? What's the algebraic inequality? Christina? Okay, -4 is greater than X, but maybe we'll write it like this. X is less than -4 for people who do better with the variable on the left. But you could write it the way you did say it, Christina. So you could say -4 is greater than X, or we could write it as X is less than -4. How about this end? What's that one? Cole?
4, or X is greater than 4.
Okay, you guys agree?
Yeah.
Okay. Is this an and or an or?
Or,
This is an or. How do we know it's an or? How do we know this is an or? Ricky, why?
Because it's not shaded in between, it's shaded on the outside, it's like, it could satisfy one or the other, but it can't satisfy both.
We only have values out here, then we got values over here. They're only satisfying one or the other. There was no overlap, was there? Now, when you talk about it being shaded between, that was like an overlap. This one had no overlap. This is an or. When it's an or, can we put it together with just one X in the inequality statement? No, we would leave it just like this. Okay, you do the last one, number 3 on your own. Come on up, Michaela T, and do it up here for us. They can compare their answer to yours. You can't scroll it over, so you're gonna try and sneak it in there, okay? Okay, agree? All in favor of Michaela's answer, hands up in the air. Oh, popular answer. All of you, anybody want to challenge her? Okay, Isaiah, do you want to challenge? Oh, you're still.
Oh, wait.
You aren't? Okay, Isaiah, what do you think it should be?
I think it should be -1 is, -1 is less than or equal to X. And
It is. That's what it is.
Okay, -1 is less than or equal to X, and, should I use the word and, did you say?
no, we can, but,
Oh, I don't think.
and, X is greater than or equal to
Okay. So, what do you think? Is Isaiah right and you guys are all wrong?
No.
What's wrong? Well, then what's wrong with Isaiah's? What's the problem? Morgan?
It's shaded to the left instead of to the right for X.
Okay, it's shaded to the left of 1, which means
It's less than.
is less than. So this should have been written X is less than or equal to 1. And then when we put them together, we would have what Michaela and company had.
Yeah.
Okay. Did we convince you? Good, okay. Let's go back and start solving these then. So when you're solving and inequalities, whatever you do to one region, there aren't sides to these and ones. There aren't sides. We can't talk about sides. We talk about regions. So when you're solving and inequalities, whatever you do to one region, you must do to the other two. So once you decide what you're going to do to solve it, you better make sure you don't only do it to that part, but you do it to the other two regions also. Now, in an inequality, you're gonna be looking at the middle region where the variable is, and you're gonna say, what do I have to do to get that variable alone? And then whatever you do there, you're gonna go out and do in those other two regions also, okay? So let's look at number 4 here. What would we do to start solving that one? What would we have to do? Christina? Subtract 2 to get x alone in the middle. So we would subtract 2, but we also have to go over here and subtract 2, and over here and subtract 2. You should be doing it 3 times in an and inequality. Okay? Whatever you do to one region, you must do to the other 2. Well, class, -3 take away 2 is? -5. Did we multiply or divide by a negative? No, so we can leave the symbol going the way it is. The x is now by itself because those guys take care of each other. 7 take away 2, 5. Do we have another step to do?
No.
No, we just have to, this is our algebraic solution, and now yes, we do have to graph it. Okay. So we have -5, we have +5. What kind of circle at -5?
Open.
Open. When we read this from the inside out, it says x has to be greater than -5. So which numbers are greater than -5? To the left or to the right? To the right. So we'll start shading to the right. But we're not going to go very far because we know that it also has to be satisfied by the other one too. So let's look at this one. Should we have an open circle at 5 or a closed?
Closed.
Open.
That's what it
This
is.
says x is less than 5. Those are to the left, but they have to can only go as far as the -5 because they have to be, we are only doing the ones they share in common. So even though we would shade the first one all the way to the right, we would shade the second one all the way to the left. In reality, there's only that one region where they're overlapping. So here is our graph. And you're going to make sure you can see that it is shaded in between those. You can tell that it's open circles.
0.
Okay. Okay, let's look at number 5. What would we do first in that one, Riley? Cole? Subtract 1. Because we got to get the 2x alone. We're not going to worry about the fact that it's a 2x right now. We're going to get rid of that +1. So if we subtract 1 there, we have to subtract 1 in the other 2 regions also. -3 take away 1 classes. -4. Did we divide or multiply by a negative?
No, it's the same.
No, so the sign stays. 2x is less than 9. Okay.
Wouldn't it be 8?
Oh, 8, yeah, do the subtraction. That would, good catch. Oh. Okay. Now what are we going to do next? The other Michaela. Add 4? What's the x we want to be alone? What do we want to do? What do we want to do to get that x alone in the middle? What do we need to do? Riley?
Subtract 2.
No.
Oh my
Hunter? Hunter's got 2 hands up. He's so convinced he knows the answer. What? Divide everything by 2. X is being multiplied by 2, so we need to, oh, careful. We need to divide everything by 2. Okay, what is -4 divided by 2? -2. Did we divide by a negative?
Yes.
No.
We divided into a negative. Did we divide by a negative? No. And we have x alone, and 8 divided by 2 is?
Maybe 4.
+4. So we have anything else left to do for this solving part?
No.
No, x is by itself in the middle. Go ahead and graph that. What would its graph look like?
Or closer to that -2.
No, just do it. Just do it, and then you can check to see if you agree with me. Okay, that's solving and inequalities. Now let's do one or inequality. When solving or inequalities, solve each independent of the other. In other words, don't let your brain say, what I did in the other one, I gotta do over here in this one. They work independent of each other. So, we have 3x plus 2 is less than or equal to -7, or the other inequality to make up our compound inequality is x plus 4 is greater than or equal to 4. Now we're back to just doing the same thing on both sides because we don't have 3 regions. So what are we going to do in this first one? What's our first move in this one?
Subtract 2.
We're going to subtract 2. So because we did that there, does that mean we should run over to the other one now and subtract 2?
No, we should just finish
No.
this one first.
Finish this one, do what this one requires. So we have 3x is less than or equal to, Hunter, what do we have?
Oh, that would be.
Okay, thank you. Okay, what are we going to do next, Brooke? Okay, divide both sides by 3. Do we switch the inequality symbol?
No.
No, we did not divide by a negative. -9 divided by 3 is what, Morgan? -3. Okay, that, we're going to bring down the or. That's part of our solution. Or, what are we going to do in the next one to solve it? Subtract 4. And after we subtract 4, x is already by itself, and we have
0.
a 0. X is greater than or equal to 0. We're going to bring that down, and we're going to write it all. We don't put it together, we just have the word or between it. So our algebraic solution is x is less than or equal to -3, or x is greater than or equal to 0. So let's get that graphed. -3, 0, closed circle at -3, shaded
To the left.
to the left. Or x can it be 0?
Yeah.
Can be 0. And what other numbers can it be?
And to the right.
Numbers to the right of 0. Okay, so we have lots of options for x, but we also have some options, some non-solutions in between there, right? Okay, so questions?
Let's always shading into the middle.
Okay, when it's and, typically, we can't use the word always, but typically it is shading into the middle.
I do have a question.
When it is an or, typically it is, that looks like you're shading out from, okay, Vicky?
When will we ever use this in life?
Oh my.
Don't say that.
We are not.
Bye.